we will solve the system of equations for positive integers x and y. The system is x cubed minus y cubed equals 91, and x minus y equals 1. We'll proceed step by step using factoring and substitution, and end with a simple, real solution. Recall the factorization of a difference of cubes. X cubed minus y cubed equals, open parenthesis, x minus y, close parenthesis, times x squared plus x, y plus y squared. Because x minus y equals 1, the first equation becomes x squared plus x, y plus y squared equals 91. From x minus y equals 1, we have x equals y plus 1. Substitute this into x squared plus x, y plus y squared equals 91. That gives, open parenthesis, y plus 1 close parenthesis squared, plus y times open parenthesis, y plus 1 close parenthesis, plus y squared equals 91. Expand each term. We get y squared plus 2y plus 1, then plus y squared plus y, then plus y squared equals 91. Combine like terms to get 3y squared plus 3, y plus 1 equals 91. Subtract 91 from both sides. 3y squared plus 3, y minus 90 equals 0. Divide everything by 3. Y squared plus y minus 30 equals 0. Factor the quadratic without using the quadratic formula. We need two integers whose product is negative 30 and whose sum is 1. Consider factor pairs of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. To get a sum of positive 1 with product negative, we choose plus 6 and minus 5. Therefore, y squared plus y minus 30 factors as open parenthesis, y plus 6 close parenthesis times open parenthesis, y minus 5 close parenthesis equals 0. Set each factor equal to 0. We get y equals negative 6 or y equals 5. Since we want positive integers, we take y equals 5. Use x equals y plus 1. With y equals 5, x equals 6. Let's verify both equations. 6 cubed minus 5 cubed equals 91, and 6 minus 5 equals 1. Therefore, the unique positive integer solution is x equals 6 and y equals 5.